right, folks. Well, first, welcome to the first session of 2026 of Alchemy's in the Lab. We are going to kick this off in style with our friends Arctic Wolf. We got a lot of great guests, and for those returning, welcome back. And for those who are new to Alchemy's in the Lab, we run these once a month throughout the year, and we maintain a pretty good schedule, and we're fully booked for the year, if you can believe that. So I'll share some insights to that later on in our session today. But we are going to jump in and we're going to focus on the endpoint and endpoint security and, really getting through the noise of alerts and how to respond better to those alerts. And with me today, I have a great panel. And for those who don't know me, my name is Pete Downing. I'm the host of these webinars, and I wrangle all the speakers and try to get good topics for y'all. So at the end, when you exit out, please do take the survey. I do pay attention to those, and we try to make these better every time. All right, with us, I got a friend in his first time on an Alchemy in the Lab, or first time in a long time, Mr. Tim Rieger. So Tim, give yourself a quick intro. What do you do for Alchemy, and where are you based?
Yeah, absolutely. So thanks everyone for joining. Tim Rieger. Like it says on the screen, I'm a solutions architect here. My main focus here at Alchemy is cybersecurity. I've been doing cyber for the last 15 or so years. And I am based out of Minneapolis, Minnesota, right down the street from Arctic Wolf's headquarters. So thanks everyone for joining.
Awesome. And next up, we got Ross, who's with Arctic Wolf. And Ross, I'm going to try to say your name, Rosenwig. If I said that right, I'll give myself a high five. But you're sitting somewhere cool today. And how long have you been with Arctic Wolf?
Thanks, Pete. Yeah, my name is Ross Rosenzweig, and I've been with Arctic Wolf now for just about a year. Arctic Wolf, what you may not know, acquired the Silence technology about that time ago, and I came across with that acquisition. Normally, you'll find me sitting in San Diego, California. I happen to be in Madrid today, so really happy to be here with all of you today, and thanks for having me.
Yeah, and thanks for jumping in. And yeah, I wish I was in Madrid getting some paella too. So, and then behind the scenes, we got Paige Packard. Paige, just give yourself a quick intro. What do you do for Arctic Wolf? And you help keep me honest in the channel. So.
Yeah, 100%. Senior channel account manager, Paige Packard. Been with Arctic Wolf for 7 years this month, which is wild. Work to help grow and foster the partnership between Arctic Wolf and Alchemy.
Awesome. Well, thanks for everybody for jumping in, and thanks folks for joining us today. We got a great panel and great topic, and we're gonna kind of set the stage because he and I were talking earlier this week, and it's like I kind of got thinking about it. I was like, MDR EDR has been around a long time, and but it's changing. And so, Tim, I kind of put the question out there: why should folks reevaluate kind of their MDR EDR strategy right now?
Yeah, absolutely. So I think it's changed enough over the years that if you're still thinking about it like you did 5 years ago or so, you're probably kind of underestimating the value that you can get out of these platforms. If you go back a few years, MDR looked mostly like outsourced alert monitoring. You plugged in your EDR, your SIM, or kind of whatever telemetry you had. It would go to whoever was monitoring it 24/7, and they'd get the alert and they'd basically throw it back over the fence and tell you to kind of go fix that. It checked that 24/7 box, but it didn't really solve the problems that SOCs were having. Too many alerts, not enough people, and slow investigations. And you were basically kind of just renting out those eyes on glass. What's happened in the last few years are kind of three main shifts, I think. MDR providers are switching from alert feeds to kind of really outcome focused providers. It's really switched from we'll kind of notify you when something happens to we'll help you detect, contain, and close loops faster. MDR is now judged on time to detect, time to contain, and how much work they actually take off of your team's plate. The second thing is really kind of it has moved from single tool visibility to whole environment visibility. Most environments today have a mix of multiple different telemetry sources like endpoint, cloud, identity, SaaS, and network. Modern MDR platforms aren't just watching one, they're correlating the data across all of those platforms. So you can kind of get one story versus a bunch of different alerts that you have to try to correlate yourselves. And then the third shift, and this is a very recent shift that we're seeing in the environment, is from a human-centric detection and response to more driven by AI and having AI-assisted response. What we have seen is the explosion in telemetry over the last 3 to 5 years is too much, even when you outsource to an MDR provider for that MDR provider to handle. So we are now introducing capabilities with AI to get in there and to collapse those thousands of raw events into a much smaller set of high confident incidents. On top of that, the business side has also changed. Pricing is becoming more predictable. And the expectation now is that a co-managed partner is there to understand your environment and mature with you, and not just be that kind of black box that you're firing off all your data to. So really, the mentality around this should shift within your environment, and you're looking to get a lot more from these providers these days.
Awesome. And you've been around this space a long time, and
Yep.
and so I'll kind of let you tee up Arctic Wolf, but why Arctic Wolf based on your experience?
Yeah, I mean, there's a few different things that kind of really stand out to me, and this first one I think is the one that I've seen for 10 years, is that they actually operate like a security operations partner, not just someone who's monitoring your technology. In the engagements I've been a part of, their concierge security team takes the time to learn the environment, tune detections, build playbooks that align with how the customer's team works, not just how the tool works or how the Arctic Wolf SOC would like it to work. That's a big deal for lean teams, so that they don't have to babysit a service provider. Secondly is more around the technology. I think the Aurora platform gives you that connected view across all of your telemetry sources like endpoint, cloud, identity, and network. And then they layer in that world-class MDR service on top of it. That matters when you're chasing things like identity-driven attacks or lateral movement. You want one coherent incident narrative, not a bunch of isolated alerts. And third is kind of something that we talked about in the last section. They're really leaning into leveraging artificial intelligence to kind of make the whole process more seamless and more rapid for their customers, which we've seen become very meaningful. And they're not just shouting AI. Like you said, Pete, they're not just shouting AI because AI is the hot topic right now. So when you combine all that, the partner mindset, the platform coverage, and real noise reduction, Arctic Wolf lines up extremely well with where the MDR or EDR market has kind of transitioned to in 2026.
Awesome. Well, I appreciate your insights, Tim, and that's going to bring us over to Mr. Ross. And you're going to take us through Arctic Wolf, what's going on in Aurora, and why we should care. So, I'll let you take it away now.
Once again, my name is Ross, and I'm the Director of Sales Engineering here at Arctic Wolf. The technology that we're going to talk about today is not new. It's actually a technology that I've been around for about the last decade. But Tim so beautifully kind of laid out what most people know Arctic Wolf for. Our open XDR platform, powered by the Aurora platform. It is, the concierge service that Tim had referred to, as well as the security journey, right? Which is really what we're coming here to talk about today, right? The sort of the next step in what Arctic Wolf can offer, really kind of bringing that down directly to the endpoint. Guys on the Alchemy side, just an FYI, I can't see the chat. So if you guys wouldn't mind just jumping in and let me know if there are some questions as we move along, and we can pause and take them as they come. But I really want to kind of start, by talking about something that the Arctic Wolf team has really, sort of recognized. And I think it's probably something that all of you probably are recognizing as well. Although, it feels to some extent like, the technology in our industry has become, somewhat commoditized. The reality seems to be that, year over year, we continue to spend more money on our cybersecurity, posture, right? And we're going to talk about endpoint security today. So, perhaps let's keep it focused there. But even though year over year we continue to spend more money, we're not seeing different outcomes, right? We're still continuing to see, breaches continue to rise, and the cost to responding to a breach, continuing to rise as well, right? So, it kind of gives you the thought of, we got to start looking at this differently, right? We got to start, doing something differently, because doing the same thing over and over again just isn't solving the problem. Now, I mentioned that the Aurora technology is not new. The Aurora technology, as I mentioned, has been around for about 15 years. We began, developing these products back in about 2015. And what's important about that is that, this technology was the first in our industry to bring artificial intelligence and machine learning to endpoint security. To be clear, I'm not saying we invented AI. That would be ridiculous. But we are the first to apply it to these types of use cases. And what that means is that, we have the longest running, continuously improving predictive AI in endpoint security. Which, when you think about artificial intelligence, and we're going to talk about that quite a bit, not all AI is applied equally, and not all AI is measured equally. So when we think about artificial intelligence, it's really important that the maturity be there, right? Because if you start to think about immature models, right, you start to think about false positives, you start to think about false negatives, right? And you're really, in order to be able to deliver on the proposition that we want to deliver on, which is really to stop the attacks before they begin by smothering the environment with a foundation built on prevention, right? And that really is kind of where I want to start the conversation. And then we'll move more into, things like detect and respond. Now, the models that we're using are now on their 8th generation, and we've achieved some unbelievable levels of efficacy. In fact, when Arctic Wolf had acquired this technology, they obviously did their own due diligence, and they had a corpus of malware that you will not find in VirusTotal, which is really kind of what we all use as sort of the de facto standard, for what's known to the industry. They took this corpus and tested against our models, both online and offline. We're going to talk about that quite a bit today. And what they saw was that we were able to stop 99.7% of those attacks pre-execution, stop the attack before it starts. I'll encourage you to take a look at the VirusTotal intelligence pages as well. False positives and measuring those is not a perfect science, but the VirusTotal intelligence pages do apply that metric across, the participating vendors in the industry. And most often, you'll find us at the bottom of the list with one, or not on the list at all. But what we've seen over a 90-day running average is about 2.6 false positives, which is pretty remarkable if you think about that from an EDR perspective. Now, if you could smother that environment with prevention, and we're going to show you what that looks like in the demo. When you start thinking about us as analysts, right, or as security experts, it really gives us the time and the focus to not so much chase after those alerts that really don't matter, right, but focus on the ones and give ourselves the time to investigate and triage those that really matter the most. Throughout our talk today, I'm going to talk a lot about automation. Our product, I very often describe it as cloud enabled, right? We've got a cloud console where you'll define policy and monitor alerts and triage investigations and those sorts of things. But the product or the agent itself is quite autonomous, right? So we're going to talk about how the AI works, but that same level of efficacy that I talked about before applies to both when the device is online as well as offline, right? And I think we all know that, with a lot of technologies, there is a decay in efficacy as the devices come offline, simply because a lot of the detection capabilities live in the cloud. And we'll talk about how we differ there. So I mentioned that we do have the longest running, continuously improving predictive AI in endpoint security, and it's called Alpha AI. We began with a corpus all those years ago of about 8 or 9 petabytes of known bad and known good. So when we're training our models to understand what are the features and characteristics that are shared by the known bad versus the known good. So hold on to that for a second. We're going to talk about that some more. But if you're looking at some of the newer, sort of industry standards, things like NIST, right? And there's a lot of talk, obviously, about artificial intelligence. And they do say that it's really important, right, to make sure that, to lack of a better term, that we don't really operate like a one-trick pony when it comes to applying AI to these use cases. AI really needs to pervade its way throughout the platform. And the Aurora platform is built based on AI, and Alpha AI specifically, that powers the endpoint detection, prevention, detection, and response capability that we're talking about today, is a combination of both supervised and unsupervised training that allows us to really fine-tune the models to make sure that they can operate autonomously, like I mentioned before, but also pervade its way throughout the platform to apply a lot of different use cases. So I mentioned before, like talking about stopping the attacks before they begin, right? We apply artificial intelligence pre-execution to stop unsafe software from executing in the environment. We also apply AI more behaviorally for those post-exploitation, tactics, techniques, and procedures, and in order to be able to stop those things again as well. A newer implementation of AI in our platform is an AI security assistant, a local language model that's embedded throughout the platform. It's really there to help you make sense of the things that we're showing you, and to help provide that remediation guidance, threat intelligence, mappings back to MITRE, really to help you make sense, as I mentioned, of what you're seeing within the platform. Now, before we get into the demo, I want to make sure that we're all kind of a level set here on certain things. I talked about the fact that we do pre-execution prevention, and we also do behavioral detection and response. For pre-execution prevention, I'd like to talk about that a little bit. That was the very first use case that we applied artificial intelligence for. And if you look at the left-hand side of the screen, you can see that, we're not just looking at files anymore, right? We're training on a number of different signals, from files and documents to runtime behavior, network activity and scripts, and all sorts of things. Now that we're a part of this unbelievable platform, right, that observes, over 8 trillion signals every day, the opportunity here just continues to grow, right? But let me talk about this from the perspective of that very first use case, because I think it really goes a long way to help you understand how this all works. I mentioned that we began with a corpus of about 8 or 9 petabytes of known good versus known bad. I also mentioned that we combine both supervised and unsupervised training. We start with unsupervised training, right, where the models are learning what are those features and characteristics that are shared by the known bad versus the known good. It's really important that in this phase that we don't talk about behavior, right? Because if we're talking about behavior, then it's too late to prevent, right? We're responding, right? But in order to truly prevent things, it has to be pre-execution. So we need to be able to train the models to look at those features and characteristics intrinsic to the files themselves that we can use to determine whether they're safe to run or not. So it's all of those things. Those are the things that we're looking at. So what I want you to think about is the compiler that was used, resources, keywords, imports, even things that us as human beings would never be able to interpret. Entropy between sections of the file is a great example of that. We then bring the humans into the loop, right? We bring the humans into the loop so that we can classify those features, right? Make that ultimately that binary decision. Is it safe or is it unsafe? And then, ultimately, progress the model into production. Now, these models are not being trained in customer environments ever. We train them in a massive compute environment up in AWS, where we have many models that are always competing for the highest levels of efficacy and the lowest levels of false positiveness. When we have a model that emerges as a winner, we take that model, a copy of it, we generalize it, right? We generalize it because we want to make sure that it's just as effective at detecting and preventing those threats that we've never seen before, those 0 days, as well as it is against those things that we trained the model against, right? The known is, is sort of table stakes. Once we do that, we then miniaturize the model. We miniaturize it so we could place it down on the endpoint, right? A copy of it locally down on the endpoint. So when that device goes offline, when that device has no connection to our cloud infrastructure, that device is still fully protected, right? We won't see the alert, obviously, in the dashboard until the device does reconnect. But the detection and the response capabilities live locally on the endpoint itself. Now, ultimately, as I mentioned, we're feeding in a number of different signals. And on the right-hand side of the screen, those are the types of automated use cases that autonomous agent delivers both online and off, right? Stop the attack pre-execution is what I've been talking about. But look at things like identifying and blocking malicious behavior, preventing, C2 beaconing and lateral movement, isolating hosts or logging users off the systems. But we're also leveraging AI to make ours and your jobs easier, right? Organize alerts for situational awareness, do the initial grouping and correlation of those alerts, and drive that faster time to the outcome, right? And that's really what we're looking to accomplish. Just to give you a few examples, there's a term that we had made up, for the lack of a better way of saying it. So don't look for this anywhere else, but it's called the temporal predictive advantage. And the way that I'll define it for you is essentially it's a measure of how far ahead of the adversary are the models. And here you'll see a number of infamous malware campaigns, right? When we first started, WannaCry was what we were talking about back then. And what you see here is the time in months that we would have predicted and prevented each of these threats before that 0 day, and we did prevent them all on that 0 day. The WannaCry example, when we first began, we would have predicted and prevented that 22 months before it ever existed. You can see that the efficacy of our models are really flourishing, right? The temporal predictive advantage, our ability to stop things that we've never seen before, is approaching 5 to 6 years into the future, right? And we test that by going back and testing our older models to see how far back we would convict them. The AI is battle proven. As I mentioned, it's effective even when it's offline. And the real, sort of magic behind the maturity of the models as they get to this stage is that, this outcome is delivered, as I mentioned, with almost no false positives, as well as really minimal tuning, right? So both from a prevention perspective, and as I'll talk about from a detection and response perspective, it's almost become a turnkey deployment, right? Really kind of a big statement, but we'll come back to that in just a second. So the Aurora Endpoint Defense really does combine all the elements you would expect of a modern endpoint security solution. We spend a lot of time talking how we're applying AI to stop the attacks before they begin, or stop the threat actor before he can achieve their objectives. We shore that up with a number of other controls that are designed, to reduce the attack surface, right? To ensure that only safe and authorized scripts or commands can execute on the endpoint. The same with software, right? Only safe and authorized software can execute on the endpoint as well. We extend these capabilities to mobile protection. We defend memory from malicious use, looking at one-liners or lateral movement, process injection, privilege escalation, other types of exploitation as well. And we do all of that with an agent that's really lightweight, really performant on the endpoint. Just uses about 1% of the CPU and 150 megabytes of RAM at runtime. What I like to always say is that, we're not combining a lot of detection engines. We don't use signatures in our product. We don't use sandboxes. We don't use, heuristic engines, right? We use these very lightweight ensemble of predictive models, which really are mathematical algorithms, right? So we're leveraging the CPU to do exactly what it was designed to do, math on the endpoint. And it is how we are able to be so performant. Obviously, as being Arctic Wolf, we don't just offer this as a product, but we also deliver it as a service as well. So managed Aurora Endpoint Defense builds on this product by adding, the power of our people and our process on top of the technology, to deliver the 24/7 monitoring and all the other capabilities you would expect, including quarterly health checks, ongoing tuning and configuration, and security assistance, incident triage along the way. So let's go ahead and jump into the demo. But if there are any questions that have come along so far, happy to take those from the Alchemy team.
No questions yet, but excited.
Right.
Well, folks are excited to see the demo. So
awesome. Let's jump into it. So just to kind of lay the land for you here, right? I'm going to be moving around my screen a little bit as we step through the demo. As I mentioned before, we have a cloud-based console. We do provide multiple deployment models, however, right? So if you have areas of your environment that have limited bandwidth, or devices that you don't want to or can't directly face the internet, we could provide on-prem capability. We can provide hybrid capability, or as I'm going to show you today, how the vast majority of our customers consume us is direct to the cloud. So here's the cloud console, and we're going to spend some time here. I also have a number of, 2 to be specific, virtual machines, both of which have Aurora Endpoint Defense installed. Really, the only difference between these is that one of these I'm going to run some simulations on, where I don't have the prevention features turned on. Obviously, that would make for a very boring demo if we stopped everything before it happened. This device over here does have all of those security features turned on, so you will be able to see what this will look like when fully operationalized. In addition to the agents themselves, you'll notice both of the VMs have the task monitor open. Really, my intention here is to just show you, while you may see some peaks in CPU utilization, it's going to very quickly throttle down and remain very performant on the endpoint. So let's go ahead and get started. Over here, this is the device that we have, all of our prevention capabilities turned on. And the first thing I want to talk about is prevention. So you'll notice over here on the left-hand side of the screen, I've got a random sample of 100 samples of malware that we downloaded in the last 24 hours. You can see they were downloaded this morning at 8:44 a.m. Each of these are downloaded from public research sites and hadn't been seen prior to the last 24 hours. As I mentioned, I have the Aurora Endpoint Defense agent installed here. And I just want to start by showing you what prevention looks like and show you how performant the endpoint can be while it's delivering that outcome. Here, I'm just going to take a piece of malware and I'll go ahead and drag it to the desktop. I could wait for the engine to detect that, but I'm going to go ahead and I'm going to double click on it and attempt to execute that. You'll see very quickly that we have execution blocked alert that appears out of the sys tray. And Windows is letting me know that it can't access the file that I attempted to execute. So to explain what's just happened, right? I dragged a file to the endpoint and I executed on that, right? We operate at the kernel level of the operating system. And when a piece of software attempts to execute, right, it's going to say, hey, operating system, make some room for me, right? And so we intercept that. We pause that execution. We extract the features and characteristics from the file, and we run those through our predictive model. We cast a verdict for or against that file in about 50 milliseconds. So as you saw, in about half the amount of time it takes for me here to blink my eyes, we were able to place that file in quarantine. I want you to take a look at the CPU while I do something a little bit different. Here now I'll take, a number of different samples, right? Here's 16 samples. And I'm going to go ahead and I'm going to drag that to the desktop. One of the things that you'll find is, of course, we're going to start scanning those files, right? But those files will not disappear right away. We throttle this process, and I have a very good reason for it. It's part of the reason that we're able to remain so performant on the endpoint and not disrupt user productivity while we're delivering awesome security, right? We will scan these files, but while they're sitting there dormantly, our file watcher process will look at them slowly and begin to analyze them. We can afford to do that because if any one of these files does attempt to execute, well, we're going to scan it at that point in time. And of course, we're going to prevent its execution and quarantine the file if it's determined to be unsafe. As you can see, it generally takes about another maybe 30 seconds beyond that to go ahead and remove those files. You can see they've all been removed from the desktop. They're currently being processed, and they're going to appear here in just a second in the quarantine of the agent. And there they are. And so all the time you can see that, while the CPU may have piked up a little bit, right, it throttles right back down very quickly, even in a VM, right, that's running in a lab environment. So very lightweight, very performant while we're delivering those outcomes. I'd like to come back into the console real quickly before we talk about EDR and show you some things over here. Number one, this is the alerts dashboard, right? You navigate through our console, of course, directly here along the left-hand navigation. The console is where we'll define policy, where we can run reports, where we can manage, our endpoint detection and response capability, essentially all the features and functions of the product. This is generally where a security analyst would spend most of their time, though, within the alerts dashboard. The alerts dashboard is designed to organize the alerts and surface the alerts that matter the most, right? So you'll notice that we prioritize the alerts as our initial sort order, with the secondary sort being based on the detection time. In order to avoid a lot of the swivel chairing that we do generally in consoles, right, we will present all of the key indicators directly here on the main screen of the dashboard. This allows us to copy those indicators, filter based upon them, because the alerts dashboard that you see here is also doing all of the initial grouping and correlation of alerts. So, for example, looking at this particular alert here, right, this is a command line. I can go ahead and filter based on that alert and start to get that, sort of breadcrumb trail, if you will, without even have to beginning a threat hunt, right, to be able to just kind of see what was going on that system at this point in time that we quarantined that particular file. If I open up a given alert, you'll see that this is just one here, right? But we do group alerts in order to reduce the fatigue. We don't want you chasing after individual detections. We want you to be able to triage them as a single alert or as a single incident. So here on the left-hand side of the screen, and I'll make this a little bit bigger for you, you'll see that we have an overview of the alert itself. And when we get into the EDR side of things, you'll see all of the MITRE application listed here as well. What you'll see on the right-hand side of the screen is the contextualized detail specific to the detection that we're selecting here in the middle of the screen. We can always drill down into deeper detail, though, right? And this is where we can start to see some of what the AI is telling us. We can apply a score, a confidence score, right? How confident is the model that this file was in fact unsafe? And you can see that it was very confident. We'll also give you an optional capability to upload that file to our cloud-based sandbox. Now, I mentioned before that we don't use sandboxes. We don't use sandboxes to convict a file, right? But we do provide a sandbox for post-conviction context. So by the time that this has happened, the file's already been quarantined. It's already been prevented, and it's already sitting in quarantine. And so you lose nothing if you don't opt into this, and as an opt-in only feature. You can see the button here is grayed out because it's already been uploaded. Had I not done that via policy, I could always select that one off if I chose to do so. But what you get by detonating that in that cloud-based sandbox are a couple of different things. I mentioned before, we're doing math on the endpoint, right? So if you ask me why that file was convicted, my answer would be because the math said so. But if we detonate that file in the sandbox, what we can do is we can return back to you these threat indicators, right? Human readable English, letting you know what were those features and characteristics, those indicators that made this file considered to be unsafe. Then, of course, we'll return the output from the sandbox itself, which is still generating right now. But we'll return the output of the sandbox itself, including any of the droppers, files, keywords, imports, and strings. All of those sorts of things will be included as well. The alert dashboard, as I mentioned, will do kind of all of that initial grouping and correlation. It's one of the ways that we can actually help to reduce the fatigue. Right, so if I come in here and actually find a detection that has more than one, right, you'll see that we can kind of switch that contextualized detail right over here while we have an alert overview to what's common across all of those individual detections. So let's go ahead and create some detections.
Hey, Ross,
was there a question?
Yeah. So just quick question before you kind of jump into your kind of next segment. So it came in and the question is, do you have to have, I'm guessing they meant to say, do you have to have silence, AKA Arctic Wolf, on the endpoints? And then does Silence, aka Arctic Wolf, do application control software that tracks approved and unapproved software, or just prevents the harmful execution of files?
Great questions. So first and foremost, if I'm understanding the first question correctly, Arctic Wolf will always remain open. So if you are not using Silence, if you're not using Aurora, I should say, and you're using something else, you're absolutely welcome to do that. And we will never change that. We believe that we have something special and something better that we can offer with the Silence technology, which is what I'm showing you here today. Application control is absolutely a part of the platform. That's the piece I was talking about where I was saying that only safe or authorized software can execute in the environment. We apply application control a little bit differently, and it's really designed to help make application control easier to operationalize. Historically, application control has been difficult to operationalize. It adds a lot of friction to the environment. In order to kind of get us out of the business of really managing hash lists, the way that we apply application control is through change windows, right? So you deploy the agent to the system. It'll scan the disk using the AI to make sure nothing unsafe is on it. Once you apply application control, we don't allow any changes to the device. So no new software can be installed. No software can be removed. We won't allow any changes to any of the portable executables on the system as well. If you need to make changes, if you need to add new software, those sorts of things, you open the change window, you apply the software, and then you harden the device again. So it's a different take on application control. I believe it's easier to operationalize than the traditional methods, and it is a part of the core capabilities of Aurora Endpoint Defense. Was there any other questions?
No, that was the first question. And again, as you're scrolling past, I'll encourage you to ask questions. We got two great guys on the call today, and Ross, man, I'm learning a lot, so I appreciate this. So
awesome. So let's do something fun now. This is actually something that I wrote. I wrote a simulation, an attack that basically is a living off the land type of an attack that offers multiple stages, right? And so we'll kind of walk through that. I'm just going to run this in continuous mode so we can generate the alerts and go back into the console and begin to take a look at them. But as we kind of work through this, you can see that, the first stage, of course, is dropping a payload onto the system, which you'll see that the agent is already detecting and now has ultimately quarantined. That is the only preventative capability that I've turned on this device, because obviously I didn't want to ransom it while I was doing the demo. As this continues, we're doing a UAC bypass to elevate privilege. We harvest credentials from LSAS by harvesting the LSAS process, and we write those to a dump file. We establish persistence through the registry's schedule task and run keys. And then we apply some anti-forensic techniques, right? Clearing our Windows event logs and disabling them, and then ultimately leveraging BitsAdmin, a native binary on the Windows operating system, to exfiltrate sensitive data out of the environment, right? And so that's what the simulation is doing, and we'll go ahead and we'll take a look at what that looks like now within the console. Now, if I come in here, right, you'll notice once again that this is sorting based on the priority of the alert. I'm going to go in here and sort these now based on the last detection time, right? And we can start to see here's all of that activities from an observability perspective. We can kind of see that moving through, right? We've got some PowerShell encoded commands. We can see our escalation of privilege, right? We could see the dumping of LSAS and kind of all of those activities as they had moved along. Just like I mentioned before, right? We try to make the key indicators as easy to see as possible, right? You can always come into the center of the alert and see the individual detections, but directly from the main page of the view, right? We can come in and we can start to interact and conduct our initial incident triage. You'll notice that directly from the key indicators, we're showing you the instigating and target process. Like I mentioned before, we can filter on those. We can copy those. We can see the full command line, of course, but we can also launch the AI assistant, right? This is just one area where we can interact with that assistant. Now, I I invoked the assistant from a command line, right? So as I mentioned before, it's always in context, right? So it's going to, summarize for me what that command line does, what command line arguments are included and what those do, the behavior, how they map back to MITRE. You can see that it is highlighting all the individual artifacts that were used, and then oftentimes we'll provide guided remediations. Like I mentioned before, though, it is remediation recommendations, I should say. It is pervasive, right? So the alert summary, right? What is bits admin file upload and download operations? What does that mean, right? And so here we're getting a summary to summarize what this particular alert means. So it helps us up-level our skill. It helps us accelerate our mean time to respond. It helps us make sense of the alerts that we're seeing. Here you can really get some good visibility, right, from an EDR detection into kind of the alert summary, right? Here are all the artifacts of interest that were common to those alerts. These were the MITRE techniques that were observed during this detection. And then as I select these individual detections, right, I get that contextualized detail down below. Of course, I can continue to drill into this, right? I can drill in and I can grab a focus view. A focus view allows me to visualize the activity that took place on the endpoint. I wrote this in PowerShell, so it's very scripting heavy, and you can see kind of what these objects represent using the legend down below. But the calling cards down below, as I like to call them, will provide all of that detail, right? So as I interact with objects within the swim lanes, I generally like to start with the swim lanes up here because I can see the processes that were involved and sort of the timeline of events as they move across. But as I interact with these objects, right, I can get down into that detail below. As I'm working through my investigations, if I have questions along the way, like perhaps, what other systems in the environment also ran this particular command line, right? I can search based on using our InstaQuery, search based on that artifact, apply it to all of my Windows computers, and go ahead and submit that query. While I'm waiting for that query to run, I can continue to work through those investigations, or work through the investigation, I should say. The analyst has a lot of tooling here as well. So, the detection detail really exposes what I like to call sort of a Swiss Army knife of tools that the analyst can use, right? Whether this be your analyst or ours. Things like package deploy, right? We've got a Python interpreter that we've embedded into the service of our agent. We deliver packages out of the box mostly for forensic artifact retrieval, right? So you'll see we gather browser history, Windows event logs, things like that. But it's an extensible portion of the platform. It's a Python interpreter, right? So we can automate and orchestrate your playbook automation as it results from a detection. But what I'm showing you here is the ability to just send a package down to the endpoint, install a piece of software, remove a piece of software, change the configuration of a system, harvest those forensic artifacts, right? And when we do harvest things or pull things back from the endpoint, of course, we can choose where we'll store them, S3 bucket or some share on the network. In addition to that, we can isolate devices on the network. We have full lockdown. We have partial lockdown. Partial lockdown allows us to maintain command and control of the device while the device is isolated on your network. It's also an extensible feature because if you have other tooling in the environment, we can create custom lockdown profiles that will allow your own tools to run as well, if they should be allowed to. The last of the Swiss Army knife here that I want to show you is the remote response console. The remote response console allows us to open a shell native to the endpoint. So for example, this is a Windows machine, right? So if I ran an ipconfig, a standard command, right, it would allow me to run that. I could also send tooling down to the device. I can launch PowerShell from the device for doing things like running a task list, seeing what processes are running on the endpoint, terminate a process directly from here, clean up forensic or offending artifacts, right? So it allows me to connect to multiple systems with elevated privileges directly from the console, directly from here. Now, what was powering all of those alerts that you were seeing in the dashboard, right, was the behavioral detection engine. The behavioral detection engine maps back to the MITRE attack framework, as I mentioned before. So you'll see here, right, each one of these objects containing the individual rules for each of them represents a tactic in MITRE. Here's T1059, right, for scripting and command interpreter. We'll provide you kind of an overview of what these rules are doing and all of the sub-techniques that are covered. But in the ability to drive down the fatigue, one of the things that you'll notice is that we differentiate between detections and observations. We can set thresholds with what we want to be alerted to. Generally, we would alert to medium severity alerts and above. But what happens to all those informational alerts, for example? Well, they become observations. That way, we reduce the noise. You don't have as many alerts to chase after. But these observations are available to enrich the other alerts that we are presenting, to enrich those investigations and to help accelerate those. And so we call this lossless noise reduction, right? So we are streaming that data into the cloud, but we're just not generating a lot of noise for you. Now, each one of these tactics can have a remediation action assigned to it, right? Those could be things like deleting those offending files, logging users off of the system, terminating process trees, as well as I mentioned just a moment ago, automating and orchestrating your playbook automation, right? So as malicious activity is happening within the environment, we will stop that activity. We will automate the collection of those forensic artifacts. We'll upload those to an S3 bucket, and we'll present alert to the dashboard for the analyst to review. By the time the analyst receives the alert, the device has been contained, so has the threat, and they can begin their investigation. So let's kind of show you what that looks like a little bit. If I come over to this endpoint over here, as I had mentioned, this is one that does have all of those controls applied. In my documents directory, I have that very same script that I ran before, including the sensitive data that it's grabbing. If I go ahead and launch this, you'll notice that it stopped as quickly as it began, right? With an alert coming to the dashboard saying that unsafe activity has occurred, and we still only have those 16 samples of malware, right? So no kaboom.exe here. Why? Well, if we come back to the console and take a look at what's happened now, right? I'm going to sort this once again based on detection time. You can take a look at this alert, right? This is a PowerShell encoded command, right? And I have a policy that says we don't allow encoded commands to run in the environment. So anytime that we see a PowerShell coded command, we're going to go ahead, and in this case, we're going to terminate the process, and we're going to terminate the process tree, which you could see was successfully done here. So that's how you saw the attack stop before it started. As soon as that PowerShell encoded command ran, it terminated the process tree, and that kaboom.exe never hit the disk. But as we kind of round this out a little bit, you'll also notice that I had a playbook that had run, right? And you can see that successfully executed here. Now, I don't have a share set up here, right? So one of the options for where we can store that data is locally in the disk. And that's what I just chose to do. Obviously, in the real world, this would be placed up to an S3 bucket, most likely. But if I come into my directory here under silence, optics, refract, which is the directory we store these in, and then results, right? You can see here is that I'm in Spain, so it's 5:53 p.m. Here is that last package that ran, right? If I come in here, you can see here is my Internet Explorer browser history, right? I selected one of those packages out of the box, but of course, that is an extensible portion of the platform. As long as it's Python delivered, even if it's just a wrapper delivering another type of scripting interpreter, we can orchestrate that using our package deploy engine. As I finish here, last thing I want to show you is that the product is also offered as a managed offering as well, right? So I was showing you sort of the capabilities of the platform. What's nice about our managed offering is everything that I showed you before, all of these alerts, the transparency is all there. You get to see the same stuff that our analysts do, including the ability to interact with the AI assistant and everything that I've shown you here today. What makes this, obviously different in a managed offering is that you don't need to worry about this, right? We're doing that for you. So where you'll be spending most of your time is within, the reporting engines or the dashboards or things like that, where we can give you some visibility into your device health. What are the most common classes of malware that we're detecting? What are the top scripts and processes that are being targeted? Where's the risk coming from in the environment, right? Where the top targeted devices and the top targeted users, and what are the top incident types, and what are the incidents that were significant enough that we needed to escalate them to you. And so those appear as incidents, right? And this is what an incident would look like. With an incident, you have the same visibility to everything that I've been showing you, right? So you have visibility into all of the alerts just from a different view, both the triggered alert and all the observational alerts as well as all of that contextualized detail, the ability to interact with the AI assistant. All of that is here as well. So you don't need to move around too much to do that. When an alert is escalated to you, though, you can see that the analyst will provide a summary. The summary, in this case, describes all of the stages of the attack, highlights the risk, and provides the recommended actions, right? So confirm whether it's suspicious or not, and whether these should be allowed in the environment, advise if the activity was not expected, and then asking if they'd like us to create a filter to suppress those types of alerts in the future. If you'd like to interact with the SOC, you could do that directly here within the chat window, which is what this particular customer had done. This is where they decided, right, that that encoded PowerShell commands should not be allowed to run within the environment, which is why you saw the outcome over there that you had. In addition to that, they can interact with each other by attaching files. Of course, we maintain an audit history of all the events that have taken place. But again, by the time we've seen this, right, the device was already isolated. The attack was prevented, and then we further strengthened our prevention by ensuring that these types of commands would be stopped before they began. Right, stop the attack before it starts, like I had mentioned before. So it looks like I'm nearly out of time here. Let me stop there and pass it back to the Alchemy team, and I'm happy to take some questions as we kind of transition back over.
Yeah, so that thank you. As you guys can see, the platform does a lot. So there's going to be, I'm going to put up 2 call to actions today because, we could go for probably another half hour. You showed us this product, Ross, and it's clear you know this thing inside and out. And I think that's what's most impressive. So hopefully everybody sees that. And I'd say the first call to action is we are doing what we're calling our Arctic Wolf strategy session. And I highly encourage you to check this page out, especially some of the folks who are strongly considering a new strategy this year. And I'm just going to say, click on the link or scan the QR code and you'll see why. And you'll get to, meet up with Tim and other folks in the Arctic Wolf, maybe even come across Ross again. I don't know, Ross, if you sound like you're a busy man and know this product inside and out. So that's follow-up number 1. And then follow-up number 2 you could do is, if you don't know where to start, we do offer what we call our attack surface assessment. And that's where you get to sit down with not only Tim and his team, but even on our consulting side and really go through, like, what is your strategy, build out kind of the roadmap and figure out where you need to focus on as far as your whole attack surface and where does Arctic Wolf fit in. So these are just 2 ways you can engage with us and get deeper into Arctic Wolf. So any questions on that, don't hesitate to reply to any of the emails you'll get. You'll get a follow-on email with the recording, and I do get the replies directly. All right, and then I just want to close out with, up next, we got 3 vendors coming up in our next sessions. We got CyberArk, where we're going to focus on certificates. And if you haven't heard, certificate management is becoming a lot more interesting as we evolve into the coming years. So more on that in March. Omnissa, who, if you guys don't follow the VDI space, that's the old VMware Horizon product. And we're going to be talking about EUC and what's coming with that whole VDI and digital workspaces. And Jason Willis of our consulting team is going to jump on and join us. And then finally, we'll end late early summer. We'll go with Nutanix, and the list keeps going on and on. I'm fully booked for the year, but those are the next 3. And as always, I like to say, any last words. So last words, Mr. Tim, anything you want to leave the audience with, just something that they think they should walk away with today.
Yeah, absolutely. So I think as you get more and more embedded into these platforms, having the ability to kind of leverage a third party to assist with the volume of data and alerts that they generate, and being able to address all of the alerts, not just the most critical ones, by leveraging both a service and then the AI assisted pieces is going to be very huge for you and your team. So definitely dig in with the Arctic Wolf team on how you can do that. But thanks.
Yeah, thanks for jumping in today. And Ross, any final thoughts before you go catch your late Spanish dinner?
Like I mentioned when I began, we have to do something different, right? And what we've been focusing on for a long time now is really proving to the world that prevention is possible. And I'll always say an ounce of prevention is worth a pound of cure. So we'd love to talk to you and see how we can help.
Awesome. Well, again, thank you, gentlemen, for jumping in today. And as I always say, hope to see everybody on our next session. Again, it's going to be featuring the whole certificate conundrum with our friends over at CyberArk. And as I always say, have a great day and see everybody on the flip side.